Hello, and welcome to the lecture on multiple derivatives presented by www.free-academy.com. Now, in covering the lectures, we're always taking the first derivatives up till now. So if I were to give you f of x equals x to the third, we would go and we'd find f prime of x as 3x squared. No problem there, but the only thing we're going to drive home in this lecture is that you can find another derivative of f of x. In fact, you could go another beyond that even. And we kind of hinted towards this with the trig lectures where we found four derivatives of sine came back to sine actually. But we're just going to illustrate this a little bit more clearly through the notation and so on and so forth. I'm going to start out by graphing x to the third. Obviously, we're not drawing anything to scale here, but this is about what x to the third looks like. Now, next, let's do this color. Graph 3x squared. Now, x squared would just look about like this. Because we have 3x squared, it actually goes a little bit tighter. Now I hope it would probably be a lot more illustrative if I actually drew things to scale here. Actually, you know, I'm going to have to go and redo my x to the third because this is way off. That's a lot more correct. Alright, so we got x to the third here. Notice, at just around this point right here, we have a very, very high positive slope here. It's very near to vertical. And it's also in positive. See, let's just say if this were 1 here, like this would be like about 6. I'm actually, tangent line there. So, but if we draw our tangent line about here so it hits the point, notice this has a slope. It goes up about 6 for over 1. And then again right here, 1 over, and we're at about 6. And at the same point here, we have a very, very steep line. It's probably about 6 and 1. And I was probably getting you a little confused earlier where I was drawing the tangent line to here onto our 3x squared. Well, to explore that, we actually need to take the derivative of 3x squared. Thus, using our constant and power rules, this will give us 6x. Let's graph 6x now. So at -1, we get a slope of -6. And right here at -1, you get a slope, that is, it goes back 1, up 6. So this line follows. And we're starting to get into a bit of a mess here. Fortunately, we don't need to explore this any further, really. Derivative of 6x is 6, straight line across. Derivative of that is 0. Hopefully this graph gave you a little bit of feel into how all the derivatives are related. I know this turned into a bit of a mess. I'll probably have to do another lecture where I go into that more clearly. But in any situation, you should be able to take a look at a graph and its derivative and say, hey, this makes sense. And I would recommend practicing that. Before I let you go for today, I'm just going to go into this notation here. F of x, when it's no derivative, we have nothing on it, just f of x. First derivative, we always denote with the prime. We've used that before. And for second derivative, we'll use 2 of those little hash marks. Anything beyond that, typically we just use numbers. F of 3, f of 4, f of 5. Another thing that you'll see very, very common is a capital F for no derivative, lowercase f for its derivative. Capital G, and little g for its derivative. That's another common one. If you're taking the AP exam, you will almost certainly see these. And that's all I'm going to leave you with for today.